Hi, Algebra 1. As we go into lesson 6 here, we're going to be looking at quadratic equations, but in the context of falling objects. The way that gravity affects falling objects can be modeled with quadratic equations. So here we go. As you look at this, maybe you're noticing that it looks like we're tracking something falling from a building. Maybe we're noticing that it's falling a certain number of feet in a certain number of seconds. And what do you wonder? Well, I noticed that with each second, it's falling further and further and further. So I wonder, is there a maximum amount that it's going to fall in a second? And I also wonder, how can we model this? Is there an equation we could use to figure out how far something has fallen in a certain number of seconds? This was kind of a trick question because we have to remember it's a 500-foot tall building. And as I can see that it's falling further and further with each second. So between 5 and 6 seconds, I can assume here that it's going to fall more than 144 feet, but it's only 100 more feet to the ground because it's 500 feet tall. So at 6 seconds, it's going to be on the ground. It'll have fallen 500 feet. Now we have Jada looking at this problem, and she wrote down that all the multiples here, or all these numbers are multiples of 16. So 16 is 16 times 1, 64 is 16 times 4. So she noticed that 16 goes into all of them. And then she noticed that these 1, 4, 9, 16, 25 are perfect squares. It's the same as 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. And those numbers correspond to our time. I'm going to put down t for seconds, meaning 1 second, 2 seconds, 2 squared, 3 seconds, 3 squared, so on and so forth. So I'm going to go ahead and write an equation here saying that the distance d that the rock has fallen is going to be equal to 16, that's constant in the whole thing, times the t, the number of seconds, squared. So if I'm going to predict how far it's fallen in 7 seconds, and we're going to assume now that the building is tall enough that it's not going to hit the ground, I would plug in 7 for t, and then I just do my multiplication and end up with 784 feet. Now D is asking us to write the equation, and we've already done that right there. As we go on and do more and more problems with falling objects, you're going to see this 16 show up a lot. This is a constant for the planet Earth. This is the acceleration due to gravity, or how fast do objects speed up when they're falling because of the effects of gravity. This 16 does have a label. It would be 16 feet per second squared. So that is how fast it's getting faster as it falls.